Okay, so the third reaction then of the alcohols is the oxidation process. Now, what we use when we're doing oxidation of the alcohols is we use potassium dichromate mixed with sulfuric acid. There's the dichromate and there's the hydrogen ions from the sulfuric acid. So this is an oxidation mixture, and if you just check the oxidation states here, the oxidation state of chromium there is +6, and over here is +3. The oxidation state has reduced, so that has undergone reduction, which means whatever it will react with will have undergone oxidation, which makes this an oxidizing agent. Now, at this stage, what I would normally do is I'd get 3 boiling tubes out, I'd put a primary alcohol in one, a secondary alcohol in a second, and a tertiary alcohol in the third, and mix it with that oxidizing mixture, the potassium dichromate and sulfuric acid. Put it in a water bath, and what we would see is that the primary alcohol has undergone oxidation because the dichromate has gone from orange to green. The secondary alcohol has also undergone oxidation because it has gone from orange to green again, whereas the tertiary alcohol doesn't undergo oxidation. So, and this is why that classification is so important to really determine how they react. And we're going to have a look at each of those in turn. And in this clip, I'm only going to look at the primary alcohol. So the primary alcohol then, when that reacts or when that oxidizes, it's actually a two-step process. So first of all, the primary alcohol can oxidize to form the aldehyde, and then if the aldehyde remains in that oxidizing mixture, the aldehyde can then be oxidized again to form the carboxylic acid. Now, if we look at what's going on in each step, we'll just have a look at the first step. What we're removing in the first step is that oxygen there and a double bond being put there, and one of the hydrogens on the carbon that it's attached to. And that gives me the ethanol, which is the aldehyde. In the second step, what's happening is we're inserting an oxygen in there. And if you remember the criteria that we use for oxidation can be one of 3 things. It can be the loss of electrons, or it can be the addition of oxygens, or it can be the removal of hydrogens. Of course, we use this one. This is our kind of proper definition, but it's always worth bearing in mind that addition of oxygen and the loss of hydrogen is the same. So in step 1, we lose hydrogen. In step 2, we add oxygen. So there's our kind of oxidation processes that are going on there. Now, when we make them, we use really the structure of the molecules to determine what process we're going to use, because ethanol, because it's got an OH, means it's going to undergo hydrogen bonding. The carboxylic acid over here, the ethanoic acid, that's got an OH as well, which means that will also do hydrogen bonding. But the ethanol, the aldehyde that we've got here, we don't have an OH, and because it doesn't have an OH, it can't hydrogen bond. In fact, all this will do is permanent dipole to permanent dipole forces of attraction due to the D- and the D+ in the molecule. And of course, that's weaker than either of the hydrogen bonds, which basically means that this one here, the ethanol, will have a lower boiling point than either the alcohol or the carboxylic acid. So the process we use to get the aldehyde then is distillation. We distill it off as it is formed. Now, I just want to kind of talk about that one a little bit in terms of the distillation process. So a distillation process, basically you have your flask there, which we then have a side arm up to there, and then we have a thermometer going in there and a cooling jacket or a condenser. Now your mixture is in here, so your primary alcohol is in there with your potassium dichromate and sulfuric acid. So here's what happens. So long as you keep an eye on the temperature and keep it below the boiling point of the aldehyde and the carboxylic acid, but above the boiling point of the aldehyde will evaporate. And as it evaporates, it goes into the condenser, which then forms a liquid, which we can then collect over here. And what happens there is we get our aldehyde collected over here. Any unreacted primary alcohol remains there, and of course any carboxylic acid that may form will also stay there as well. So what we end up with is our pure aldehyde here. If, however, I want to oxidize it from ethanol past ethanal all the way to ethanoic acid, I have to use reflux. Now, refluxing, the apparatus looks like this. What we do is we have the condenser on the top now. And what this does, it stops any liquids from escaping. So down here, I've still got my primary alcohol, as I've got before. This time, though, as anything evaporates, the condenser converts it back into a liquid and it drops back down into our oxidizing mixture here. So our primary alcohol, as it forms the aldehyde might evaporate, but the condenser drops it back into the oxidizing mixture, which then converts it to the carboxylic acid. So when we want the carboxylic acid, we do it this way, using refluxing. When we want the aldehyde, we do it this way, using distillation. So anyway, that's enough about that for now. I'll pick up the next one in the next video, doing the secondary and the tertiary alcohols.